Okay, so let's look at function notation and explanation. So we have this this f of x, g of x. Really, function notation is, if we go back to linear functions, right? We have this y equals mx plus b. You probably learned this in pre-algebra and learned about functions in pre-algebra, but if we kind of look at this in terms of, let's say y equals 2x plus 3, right? We'll just put in something for m, something for b. We have now what we call an equation. So in fact, let's just use 3x plus 3 because that's what we have over here. We have f of x equals 3x plus 3. So how are these two things similar and different? Well, this is an equation, and this is a function. Okay, now ultimately they are the same thing in terms of the fact that we would apply them the same way, but in reality, f of x, this terminology is read as f of x, and it means the function of the input x, the function of the input x. And now I'm saying this very specifically because this is a hard concept for so many students. And so it says the function of the input x. And so where is the input? The input, well, I'm going to redraw it a little bit for you to see. The input is this value right here. That is the input. And what I mean by that is they're saying, okay, I plug in some number, right? Plug in some number to x. I do the work, and I get an output. Well, therefore, f of x, this whole thing, is the output. So just the little value here is the input, and then whatever we get out is the output. And that's why we can say f of x equals y, but another word for equals is the word is, right? So f of x is just a fancy way to replace y to kind of evaluate functions at different values. So, or equations at different values in using function notation. So what that looks like is actually pretty simple. That's just like kind of a long explanation to kind of guide you to do this. So this right here is the input. So what do? I go over here, I'm going to rewrite it as f of 4, right? It's f, we read it as f of x. So then I'm looking for f of 4, meaning I'm looking for the input of the value 4. So what do? This is actually much simpler, but the concept is deeper. It's much simpler to apply, but the concept of it is deep. So 3 times 4, right? It's 12 plus 3. So f of 4 equals 12 plus 3, which means that f of 4 really just equals 15. And so what that simply means is that I have an input, which we know inputs and outputs to be ordered pairs, right? X, Y. I have an input of 4. I get an output of 15. And I would get the same thing if I used the equation here. If I plugged in 4 times 3 plus 3 gives me the output of 15. So we use function notation for lots of reasons. It helps us identify specific values we're looking for. It also helps us think about things slightly differently, but it allows us to combine equations in a much more easy way. So, for instance, I have this situation in the next one. I have this f of 3 plus f of 6, right? It's not f times 3, so a lot of people think the f next to the parentheses is multiplication, but it's notation, and so it's not the same thing as that. So really what that means is I'm going to take 3, I'm going to say f of 3, I'm going to plug it in, but I'm going to plug it in for x in both. Notice I only plugged in 3 because I want to find the output when I plug in 3, and of course the output when I plug in 3, and remember organization, I should square 3 first, so 3 squared is 9, and 9 times 2 is 18, minus 12 plus 1, so 18 minus 12 is 6, and then 6 plus 1 is 7, so my output for the input of 3 is 7. So then I'm going to redo the exact same thing, but instead of using an input of 3, I'm going to use an input of 6. So I'm going to say f of 6 is equal to 2 times 6 squared minus 4 times 6 plus 1. Okay? And what do I end up with? 6 squared is 36. 36 times 2 is 72. Minus 24 plus 1. And that is for the input of 6. So 72 minus 24 is 48 plus 1. So my f of 6 is equal to 49. So that means when I kind of go back, I take f of 3, my output is 7, right? So this is the output I got when I plugged in 3. So I want to find the output when I plug in 3, but then I want to add it to the output I get when I plugged in 6. And so I add these two numbers together to get 49 plus 7 is 56. So the output of f of 3 plus f of 6 is 56. It's kind of tricky, but you're going to have lots of examples to practice that with. And so here is a slightly more complicated problem. And my guess is you have examples to do work with that look just like these. Now the letters could change. It could be F, it could be G, it could be H, and that gets a little bit of experience will help understanding why those things can change, but they're just representing different graphs on the same graph or on different graphs. So here we have g of x is equal to 4x squared plus 2. So I just changed this to show you it could be any letter. And so we want to find, let me just find 2, and then we have this g, and then we have this x plus 2. So we know that this is g of x plus 2 if we kind of go back to the explanation of the input of reading f of x, right? So this would be g of x, but it's x plus 2. But then this 2 out front is actually in front of it, so it actually means multiplication. And so what this is saying, if we go back to knowing that this is all f of x, which is all the output, it is saying whatever I get after I do the work, I'm going to multiply it by 2. So let's take a look at what that looks like. So I'm going to just put this over here just so we can see. Just organization-wise, it's cleaner. Maybe you'll learn techniques later on. And now I'm going to have 4x plus 2 squared plus 2. And okay, so this is going to be a little tricky for those of you who haven't done any kind of quadratics yet. But when you have this x plus 2, this means with this exponent squared, it means that you have 2 of these situations, right? So I have to multiply these two things, then multiply by 4, then add 2. So this is going to be x squared plus 4x plus 4. I know that from experience. I will go through a method for how to do that at some point, but it's not about this outcome, it's about the application of when you plug this in. And so now I would distribute, right, and I would get 4x squared after I distribute the 4 to all of these. 4x squared plus 16x plus 16, and then I have this plus 2 right here at the end, right? And since I'll keep the parentheses there, I'll put an equal sign in front, but because the parentheses can just drop because there's nothing to be done, I can just add it together, plus 18, and now I am almost finished. Okay, why do I say almost finished? Because I'm going to put this equal sign just a little bit further away. I'm going to go back to this 2 that we forgot about because it's 2 times this, and I'm going to put brackets around each of these equations. Just put the 2 out front. I'm doing it at the end just so you didn't get lost, because that 2 is still part of the problem, right? And so I don't need brackets anymore here because I have parentheses, and so brackets are just another set of parentheses. That's all they are. They are not anything super challenging. It's just that we use brackets in problems with parentheses because it looks weird to have parentheses around parentheses, so it's just a cleaner way to visualize it. And so after I multiply, all of the, well, actually I should be careful. This has to go around. I do need the brackets here because I had to add the 2 first. So after I get to this, I am multiplying it by 2, and then of course we will put this answer way off to the side here. So 2 times 4 is 8x squared. 2 times 16 is 32x, and 2 times 18 is 36. And so this would be the outcome, right? This is our 2 times g of x plus 2. And then this last one, it says find f of x plus g of x. This is a little bit easier. All that means to do is just take 2x plus 4 and add 5x minus 2, right? I put parentheses around just because it's grouped, right? This is my f of x equation, and I guess expression, and this is my g of x expression. Basically, it's asking me to add these two expressions together. That's all it's asking me to do, and so parentheses can separate. I get 7x because there's an addition between them that don't matter, and I get minus 2. And so this is what you get when you add the two expressions together. And that is kind of a complicated but also a thorough explanation of kind of a tiered level of difficulty of function notation